All right, so we're comparing Jim and Sarah, who did, like, they did have a test. They are arguing about who did better on the test. And Jim's z-score is given by, you take 95, his score, minus the average, which is 90, and divide it by the standard deviation of 4. And that's going to give us 5 over 4, which is going to give us 1.25. That's his z-score. Now, can you explain what that even means? He did a little more than 1 standard deviation above the average. That's what that means. He did a little more than 1 standard deviation above the average. Just a little more than 1. All right. On the other hand, Sarah, can you tell me, Ashton, what numbers would I do to calculate Sarah's?
90 minus 85.
90 minus 85 over 3. And 90 minus 85 is 5, and that's 5 over 3. And 5 over 3 compared to 5 over 4, let's get the decimal for it. 5 divided by 3, and I get 1.6 repeating. 1.66. So z-score of 1.66 compared to, actually, 1.67 if I'm going to round to 2 decimal places. It is no doubt Sarah did better. Do you see how a z-score can be handy for that? Do you get that? All right, so that's one topic. Now we also have to know a couple others, and that was inverse normal and what's that CDF thing? You remember those? These are under the button called VARS, so everybody find the VARS button. And then above the VARS button, it's distir, which stands for distributions. So go to the distir option. And then we're looking for normal CDF. What does that do for you again? I'm going to give you a 2-second reminder. You need to give it 4 things. 4 things in a row. And if you've got the newer version of the calculator, it'll walk you through it. It wants the lower, and then the upper, and then it wants a weird-looking symbol, which stands for average, and another weird-looking symbol, which stands for standard deviation. And I'll give you an example of this one. So, Grandma's Marathon is run up north. We were driving through Duluth, so it reminds me of that. And Grandma's Marathon, every year they have the stats on how long it takes people to finish, okay? And I'd like you to guess right now. I'm going to look it up for you, but would you just take a guess on, it's a marathon, it's 26 miles. I know you don't know, but what do you think the average finishing time is? Average, not the best ever, not the winner of the Grandma's Marathon, but how long do you think it takes them to run, on average, the 26 miles? Write that down, and it's going to be in hours, by the way. If you want to keep it simple, you could say like 2.5 hours. Whatever. I'm not saying that's the answer. Find out. Now, it's humanly possible that the AI is going to go, well, we weren't able to tell exactly, but I'll give it my best estimate. All right? And its best estimate is 4 hours and 20 minutes. Now, I might have biased you by saying like 2.5 hours or whatever, but yes.
I got around 5.2 and guess.
All right. So anybody else that was close in the 4 to 5 hour zone? All right, good. So there's our average is 4 hours and 20 minutes. And so how do we make that a nicer number than, because we can't use 4.2. 4 hours and 20 minutes is not 4.2. If I wanted to put in a decimal for 4 hours and 20 minutes, what would I do? Well, the average is going to be 4 and 20 minutes out of 60 is 1/3. So 4 1/3 is about 4.33. Let's go to 2 decimal places. That's the average in hours, 4.33 hours. Now, let's see what the best guess is on the standard deviation. Now, I'd like you to guess on this also, in hours. Do you think it's going to be like an hour of standard deviation, or do you think it's going to be more like 2 hours of standard deviation, or? It's got actual data, which is pretty good. So it ends up being 58 minutes, which is pretty much a 1 hour standard deviation. So we're going to put a 1 here. Then, the lower and the upper, that's kind of like this. Let's say you want to know how many people finished in 3 hours or less than that. Now, this is going to get weird because a good time is a low number. You know what I mean? A good time is a low number. So don't start with the lower of 3, because a good time is 3. So the upper end of the range is 3. And what do you put for the low end of the range? Like, don't we have to know what the fastest person was? No, we don't. What is the lowest theoretical? 0 would be fine. In fact, if you wanted to put in 1 times 10 to the negative blah, 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 you could do it with a scientific notation like that. But 0 is fine. All right. So go ahead and enter that in now using your normal CDF, and it'll tell you what I think is a very reasonable question is, what percentage of people finished in less than 3 hours? That's what this is figuring out. Please compare with the kid next to you and see if they figured it out. Did you get about 9%? All right, cool. So about 9% of people can do a marathon like that in less than 3 hours. All right. So, what if we use the same exact data, but I do it in the reverse way, and I say, what does it take to be in the top 5%? Well, you don't use normal CDF then. If you want to be in the top 5%, you're going to do the other thing under the distur inverse norm. And if I want to be top 5%, like that was my goal. I didn't want to just be top 10%. I want to be top 5% of the marathon finishers. You can figure it out. In this case, you only enter 3 numbers. Alex, do you know what to type in for inverse norm here?
It's like, I definitely need average and standard deviation.
Yes, that's here and here. Okay, let's do those. So the average is 4.33, and the standard deviation we rounded to an hour, so we're good on those. And now it's top 5%. What do you think you should put?
Like 0.95.
That is it. Nice job. You didn't get duped into thinking 0.05. Because 0.05 would mean the lowest 5%. If you want top 5%, you want the 95th percentile. All right. Alex, what'd you actually get when you typed that in? All right. Take a second and do it, and then you can verify it for the other person. I'm going to, in this case, pick Henry. What did you get?
5.97.
5 point, Are you sure it's 5 point something?
Yeah,
5.9 what?
5.97.
Mm.
I think it's because the top 5% is like.
Oh, yes. This would be the highest 5% of times, wouldn't it? So this would actually be the worst 5% of the runners. That's one of those things that gets really tricky with big number is not a high percentage. A big number when you're in a race is a bad thing. So, all right, I got duped into thinking it was 0.95, right along with you. So then, this would be told us that about 6 hours would put you as the worst 5% of the runners in that race. All right, so then let's go 0.05, which actually seems like it's bad, but it's actually a low time, and that means it's really good. And now, what do you get? Isaac, what did you get with that? Rerun the numbers.
1.35. I think that's, I guess.
Is that right? Is that what it says? Okay, all right, you must have typed something wrong. Quan, what did you get? 2.69, and that's hours. So it's about 2.7 hours. Does that feel like it's a really strong time for a marathon, given the average is like 4.3 hours? Yeah, it's a really strong time for the marathon. That seems believable. All right, cool. That's how you use all of those things. And if you really like this kind of stuff, you're like, I could see that being actually useful. I did have a friend who went through college, got a math degree, and he liked stats so much he decided to go get the master's in stats. And it's a fairly short program. It's like 2 years. And then he was able to get a really good job with his master's in stats working for a company. He worked for 3M for a long time. He had a really good career, making good money, very posh job. So, moral of the story, stats can be your whole career if you want it to be. All right. So, now we have to move on to something you haven't done in so long that last hour, only 2 kids remembered how to do the problem I'm about to give you, and it's a problem that's on your final. So if the final were today and you had a question about sequences, I'm willing to bet a lot of you have forgotten this stuff. So last hour I just kind of jumped right to the questions and I realized, oh, they've forgotten everything. So you're probably going to be right there with them. So I'm going to hit you with a question just to see, do you know it? Maybe you're going to prove that you're one of those top 2 kids that actually remembers this. All right. So if I give you a sequence that starts with 8.75 and goes to 6.75, and then it'll go to some other number. But this is important. It's a geometric sequence. I don't just want to know the next number. That actually wouldn't be too hard. I know for some of you it might be too hard, but if you could find that number, awesome. That's the easy part. The hard part is, can you remember if we start with u sub 0 equals, can you write the rest of the equation, including the domain, for this problem? And this is a very reasonable problem about sequences that by the end of the hour today, you'll feel like is very doable. U sub 1 equals, and then there was another line after that, and then there's this little n domain thing at the end. Yeah, you guys all answered a question just like this. The average on that test was high. So you knew how to do this before, but you probably forgot. I'm just going to give you like 1 minute. And if you don't remember, it's all cool. It's all cool because it sets you up to realize, oh crap, I guess I better like let him remind me about sequences so I don't fail that part of the final. Yo, so let's see if you figured it out. First off, you had to take this divided by this. And if you're like, but it just subtracts 2. No, it doesn't. It's geometric. That means it had to multiply by something. So you should take 6.75 and divide it by 8.75, and that'll give you this little number that's a ratio. It's called a common ratio. So 6.75 divided by 8.75. And you get 0.7714, and then you could go forever. But let's just say it's 0.7714. So then I'm going to take this and times it by the 0.7714. And I get 6.75 times 0.7714. How many of you got 5.2? Raise your hand if you got about 5.2. Nice. Now, what to round to? Maybe it was 5.21 if we went to 2 decimal places, but if you were around 5.21, awesome. You figured that part out. But that wasn't what stumped last hour. What stumped last hour was this equation thing. The beginning's not that hard. 8.75 is the starting term. That's what we started with. Don't you usually start with u sub 1? Yes, but you can start with u sub 0. And I gave you the u sub 0, so you knew that we were starting with u sub 0. And then, here's the part almost nobody had. U sub n minus 1 times 0.7714, and then n is greater or equal to 1. Did anybody have all of that? There was only 2 kids last hour, and there are 7 kids in this hour. Nice work. You officially kicked their butts. But still, there was only 7 kids. So do you know where you messed up? Would you be able to do a question like this now that we've practiced one? All right. Well, if you were able to do it the first time, of course you'll be able to do it the second time. So I'm going to change it just a little bit. Just a little bit. This time I'm going to give you the equation. U1 equals 6.8. UN equals UN minus 1 times 1.25, where n is greater than or equal to 2. If I gave you this, talk to the kid next to you. What's the growth rate? %25 growth rate. It's the part after the 1. In fact, I started telling you, hey guys, just put 1 plus 0.25 in there, because you remember me saying this? I know where you're going, and you're going to end up dividing this by 12 to make it monthly. Do you remember those where we'd start doing the monthly rate? And then we could like add 2.5 each month or whatever. Okay, so that's coming tomorrow. For right now, I'll just say this. All right, so then, could you find the 10th term? Yeah, but you'd have to like add 1 or multiply by 1.25 a whole bunch of times, and that would be really painful. So is there a calculator way to put this in? Absolutely. All right, so take a second and grab your calculator and go to mode. And if this is the moment where you're realizing, oh crap, my calculator's all screwed up, you can always do the second plus 712 key sequence, and that will clear your calculator out. It'll also erase any programs you have, so if you're a hardcore programmer, you may want to be aware of that. Okay. But you go to mode, and you're looking for sequence mode. It's a few arrows down, and then eventually you'll find sequence mode, and then you got to go on to sequence mode, hit enter, and then you'll be in sequence mode. And then when you hit your Y equals key, you should see this. N min equals 1. U parenthesis n equals, and then U parenthesis n min equals. Do you remember how to put this into a calculator? One hint to make life easier, you won't need the domain part. The calculator knows that part. All right, I'm gonna walk around and help people that got lost there to at least be on the right place and in the right mode. So now I made sure everybody's in sequence mode. N min is 1. I want you to think through what that means. The minimum n, the smallest n, these are the n's. So it's saying the smallest n is 1. Okay, cool. That's what I wanted. It defaulted to 1 because you usually use 1 there. Now you might have forgot this part. The lowercase u is above the 7 key. You need to say parentheses n minus 1. This n is part of the x, comma, t, comma, theta, comma, n key. There's just one key that has all those things on it. That's where the n is. This has to be a minus key, not a negative key. Finally, a normal number. It's just a 1. There's only one of them. Nobody messes up the 1. All right, u parentheses n minus 1. And then you put in parentheses, just like this. Parentheses, 1.25. Now you could put 1 plus 0.25 if you want to be pro level. And then if you think about it, the only thing we haven't told the calculator is what the u sub n min is. And n min is 1, so that's really u sub 1. And u sub 1 is 6.8. So the last thing you put in is the first number of the series. I think there's some irony there. The last thing you put in is the first term of the series. There it is. There it is. Now, if you've got that, then you need to be able to go to the table. Everybody find table on your calculator. I'll give you a hint. It's in the upper rightmost corner. And if you hit table correctly, it should say that 1 goes with 6.8. And 2 goes with some other number that's a little bigger because it's been multiplied by 1.25. Mr. Breen, what did you get for the 2?
8.5.
I assume you're rounding. Oh no, look at that. These numbers came from, oh no, they didn't come from the original. All right. Do you guys also get 8.5? All right, good. All right, and then if you just wanted to read down your table, you could find out what u sub 25 is by just keep going down here, and that would be a typically hardest question that you could have. All right, so there's your little review lesson on sequences. So I'm going to ask you a follow-up question to see. There's like probably 4 or 5 questions on the final about this. So if you're thinking, yeah, I'll just get these wrong. Well, dang, that means you just lowered your grade by 10% on the final because you just based on sequences. All right, so see if you can answer this one. Here's a new sequence. U0 equals, and you might be like, wait a minute, I thought they always started with 1. No, these can start with u sub 0 if they want. 20. Un equals un minus 1 times 1 plus 0.04. And I want to know what is u sub 3. You can use the calculator. I would. There's 2 different ways you could do it. You could type it all in as a sequence in the sequence menu, like under the y equals key. Or, if you'd rather, there's another way to do it. Just find me u sub 3 using the calc. I'll pause for a minute while you try that. Okay, just one thing that's going to mess up some people. U0 was 20. U1 feels like it's the first term, but it's not. Now, I can get this the easy way or the hard way, and I always like the easy way. I can just multiply my 20 by 1.04. That's the easy way. And I get 20.8 for this one. And then I can just times it by 1.04 again. But I just gotta not lose track of where I am. U2 would be 21.632. And since Mr. Server didn't say where to round to, I may as well just not round it at all, because then I can't be blamed for rounding too much. Too accurate is not a thing, so. And I'm gonna times it by 1.04 again. And I just screwed that up. Dang it. I multiplied by 104, so I gotta move the decimal back 2 spots, so then that would be 22.49, and I don't wanna write them forever. 22.497 is probably good enough. Raise your hand if you got the same thing as me. Awesome. You could have typed it into the calculator, into the sequence system, which is under the y equals button, and this would be awesome if you knew how to do that too. But now, last thing is some terminology. What about this is called the rate? Just say it to the kid next to you. What's a rate? The 0.04 is the rate. Now, is that 4%? Well, on the Schoology quiz, it tells you, we want you to write the rate as a percent. So you type 4%. And it says it right in the quiz to remind you, not 0.04, 4%. Okay. Then, what is 1.04 called? It's not a rate. Do you remember the name? Nope. Nope. I get what you're thinking, but the 1.04 has a name and it's called the common something. There it is. Common ratio. If you forgot those words, that is something we could test you on. What is the common ratio? 1.04. Now, this is the common ratio. Just this part is the rate. So the common ratio is that whole number. The 0.04 is the rate. The other one's called the common ratio. There's two kinds of sequences. Arithmetic and what's the other kind? Geometric. The kind that multiplies each time is what? Geometric. Yes. All right. Now I think you're ready. So open up the Schoology quiz. We will do the first problem together, because once you're started, you're halfway done. Would you read me number 1, please? Nice and loud, Max.
We have studied two types of sequences, arithmetic and geometric.
Two kinds of sequences, arithmetic and geometric.
Which one is exponential
Which one is exponential
growth?
growth? Is exponential growth where you add something every time? Is it where you multiply by something every time? So it's the geometric kind. All right. Now, as you move on, if you get stuck, I really hope you talk to the kid next to you, because you're all in the same, you're in this together. You got the same exact assignment. And if you're just too shy to talk to that person, you want to come up and talk to me, totally fine. Just don't sit there and suffer, because 2 seconds, I can help you. Last hour I had like 6, 7 people walk up, happy to help you. Just take a minute and ask, and it'll fix it. All right, that's all I got for you for today.